Hey guys, Chris here. Obviously I'm wearing my stud shirt. I was going to do a shooting video for. I'm practicing for each event for the Pyramid Cup, and this week has been really busy. I've been in the middle of a couple of real estate deals that have been very time consuming with appraisals and whatnot. So I haven't had a chance to thoroughly read the directions. I perused them and got what I thought was all the pertinent information until I saw that I need a single shot tray last night. So I'm going to machine one, and because I don't have a whole lot of time, I'm not going to go through the process of designing it on Fusion or anything. I'm going to just do it manually. So I'll show you guys really quick. And also this will be helpful because if you guys don't have a CNC machine to do it with Fusion, you can do it on a milling table the same way that I'm going to do it with this. I'm just going to control the CNC machine manually with a remote control. So let me zoom you in real quick. You can see I got this. That piece of aluminum is in the vise, and I'm on the wrong vise. There we go. And I've got the level zeroed out, and I just have it marked the height. I know I need at least that height, so I'm gonna 1/10 of a degree is all right. I'm gonna machine it down to approximately where I need to be, and then I'm gonna measure it precisely, and then I'm gonna actually do thousandth of an inch increments on the CNC, and I'm gonna put it down exactly to how many thousandths I need to take off, which obviously if you don't have a CNC machine, you won't be able to do it exactly that way, but with a milling table, you'll be able to do it pretty close. You'll be able to, measure it and then just, go down that much. If you have increments on your milling table. I don't have them on mine because mine is a drill press that just has a milling table attached to it. But if you have an actual milling table that you bought as a milling table, it should have the increments. So I'm going to set you up here. You guys can see the cut control software that I'm using. This is the software for the MR1 CNC machine. This is Fusion 360. If you guys know anything about the machining stuff, you'll recognize that. It's a very popular software. This is the software that comes with, or not comes with, but is for the MR1. You don't have to pay for it, but you can't use it if you don't have the machine. Okay, so what I'm going to do is I'm going to start by I have everything set up already as I showed you. I'm going to just move these couple tools out of the way. I have a 1/2 inch high strength steel bit in the CNC right now. And I'm trying to position the coolant. Let me position you guys so you can see the CNC machine. All right, so I'm gonna tilt you up a little bit. And then also the couple guys that I'm making silencers for, just so you can see, this is at the end I had too much heat when I tried to weld a piece onto it and it's all messed up, but that's what they all look like. I'm just doing them out of the same bar stock. So they're going to look just like that. If anybody's watching that I'm making silencers for, there's a couple of guys I'm making them for. But that's about what the internals will look like. And then I'll probably do one layer of mesh and felt around that. And then, that'll be inside a tube, obviously. Okay, so I'm going to shut this off and we're going to start on this. So this is the controller for the CNC. So that's how I'm going to do it manually. Let's see when it registers. There we go. All right, and then I'm going to, let's see if the coolant's going in the right direction. Why is my coolant? Oh, hello, let me turn this on. All right, let's aim that right. Turn it down a little bit. All right, that's good. I'll shut that off for right now. Get it in the right spot. So you see, that's why I'm glad I took the time to put the extra drain in here, because it drains very well. So what I'm going to do right now, I'm just going to take that aluminum block down. I'm going to go by 10 thousandths of an inch. And that's at 10 inches per minute. I'm going to go in a continuous step, and then I'm going to go down by, this is going to be how fast I'm moving, and this is how much material it's taking. So I'm going to start the spindle up. Where's my mouse? That's the cool thing about this remote that they have with it too. It controls everything on the computer. I think I'll do 5,000 RPM. This goes up to 8,000 RPM. It's actually capable of cutting titanium. So I've done steel on it. It's like nothing for it. All right, coolant. Okay. So we're just taking it down to, you know, to level off the face of it. We're just kind of facing it. Well, we're facing the material. I'm taking it down a little bit at a time, and I'll go across the whole block. And then I'm going to, this is going to be for the raw. I'm doing this for the Rapid Air Weapons 22 caliber. And then I have a bit that's just the right size for, it's just a little bit larger than an actual 22 pellet. So it'll make a good rounded slot for it. And this is going to slide right into the opening where it needs to be. So I'm just cutting off the top of this. I'm going to go over it probably 2 passes to get it down to that line. So this is the first pass because I'm not moving all that quick. I can actually go a little faster. Where's my mouse? There we go. Because even at the 5,000 RPMs, it's not even starting to struggle. It's just like, how fast do you want me to go? This is an awesome machine. If anybody's in the market for, and you might be in the market and not expect to be. I didn't expect to be. This thing was like just over $8,000 with everything I got, the enclosure and all that. It was surprisingly inexpensive. I mean, not that that's inexpensive. There we go. Now I'm taking a good amount of material. This thing just plows right through it. So I didn't expect to be in the market because these things notoriously are like $50,000 to $100,000, and then the robotic ones where you have, you know, like they do part of the tool changing and all that stuff. Those are, you know, up to $1 million. I mean, that's I did not expect to be in the market for this. This is for things like this for me, for a hobby. This is not something I do that makes me money. You know, I mean, a silencer, that's even on the lathe anyway. But whatever, even if part of it's done on here, like the threading or something, it's not going to accommodate putting this much money into it. I did it because I'm passionate about it. And I like to be able to make my own stuff and not depend on anybody, like right now. Looks like I need to go down a little bit more, so I'm going to make these increments very small, and we're going to do 1,000th of an inch at a time, and we're going to take this down to 10. I'm just going to move it out of the way. So this will literally move at exactly the amount that I'm telling it to. So once I hit the button, it's going to go until it gets to that point, so I have to actually lower it, because I don't want to go that far down. I want to go up a little bit. So that was 10 thousandths of an inch, and I wanted to do half that, so I just put it on one at a time and went up 5 times. So now I'm going to go to continuous jog, and we're going to do 10 on the jog speed because that's where I want to be, and I know I am. All right, and then we can start this pass. Actually, I can turn the speed up. We can go faster on this because it's already set. So now that's closer to that line, but I'm not right on it. So what I'm gonna do is I'm just gonna go down till I'm at the line in the front, which is, let's make that a smaller movement for the next one. Okay, now we can speed it up, because that's where I need to be. That needs to be continuous. I need to be here. That's better. Sorry about the noise. I know it's a little obnoxious, but it is what it is. You cutting metal, you want to cut metal, you're going to get some noise with it. Alright, just clean up the face of it. See, and this is all stuff that you can do with any milling table. So, I mean, you have a lot of capabilities even with just a milling table. All right, so I need my voice key. All right, we're gonna take this out, and now I'm gonna measure this exactly to the magazine, and then I'm going to cut it down exactly how much of a difference there is currently. So I'm gonna measure it right now, measure the magazine, and then I'm gonna take out, if any, the amount exactly that it is. But I marked it off of that to begin with, so it might be right on. We'll see. But for this, you want to use a micrometer, not just a caliper. I think it is right on. That should actually be it right there. I don't think I even need to change it. I just need to see where the channel needs to be. So this is a 0 to 1 inch, and then I have an old school 1 to 2 inch micrometer, because this you want to be pretty precise with, especially like where it is to line up with the barrel. Compared to, I mean, the width could be slightly off, but where it lines up with the barrel can't. So you want to use the most accurate tool you can. And I need to machine this part smooth, because that's a cut from the bandsaw. I need to flatten that out. Okay, I've got 62. Let's see where this is. Oh, dude, I'm right there. That's it. All right, that's what I want. That's perfect. Okay, so that's exactly the right diameter. That worked out very well. Okay, so now I need to, first I'm gonna machine that top part smooth. Actually, both sides I want to machine perfectly smooth. So, and that's gonna be a little tough. I should have started off with a finished piece, but what are you gonna do? I'm gonna back this out a little bit and get this in here. And this vise should make it pretty close to level. I mean, pretty close to flat anyway, because the whole machine is level when I installed this. So that's the thing about this machine. That's why you can get it for a reasonable price. It was about $8 grand, if I didn't mention it earlier. And that's with, I got the remote, I got the pump system for the coolant that activates with the unit. I got the touch probe that you put in the spindle. This right here and this will probe where your work is, and the tool setter is in there. It does automatic tool setting. You have to change it manually, but that'll change it in the software when you're using you know, a program to do something like this, which normally I would do, but it's time consuming and I need time to practice. I'm you know, this was not part of the plan, so these last minute things just can't take as much time, unfortunately. But I can, if I couldn't do it this way, I would have no choice but to do that, but luckily this is something that's not all that complicated, so I don't need the computer to do it for me. And neither do you guys. So let's turn that on, pull it on. All right, smooth this out. All right, we're gonna get in a little bit. Okay. Turn the speed back up. See, that's pretty darn smooth. Yeah, this thing it's totally level. So anyways, you do need to install the whole thing yourself, and that involves pouring concrete, and this whole base of this is filled with concrete. It's on the legs, but this underneath this plate that's got the vices mounted to it, that's all high strength concrete and then epoxy on top. So I had to do all that, and it was a process. Oh yeah, that came out perfect. The top, I'm gonna do this other side. Well, actually no, I'm not, because I'm gonna have to cut it anyway. So that's, the diameter is gonna be this way. So this is gonna, where's, oh, the magazine's in my hand, hello. This is gonna be like that. So now, the height really only needs to be, let's see, it's loading the pellet from right there, which I need that measurement for sure. It's going to be just, it's actually going to be pretty short compared to this. I might even take some off with the, no, I don't know if it's band, so I'm short. Let me try to measure the height with a caliper. It'll be a little easier, and then once I get it cut, I'll measure the distance for the, where the hell is the caliper? Oh. I'll measure the distance for the actual channel for the pellet. But so this is the height of the magazine itself is 1.07. Actually, you know what, let's do that with the micro. If it's over an inch, I'm not going to be able to, and it might be, I mean, that's not going to be that far off. I think it is. Oh, this goes up to 1.03. That's not bad for a 0 to 1 inch, but yeah, it's a little bit bigger. So I think I'm gonna have to, I mean, I could use the 1 to 2 inch, but I think the micrometer is good enough for this measurement. It's the channel that is really the impeccable, the most important part. So that part I just machined flat. So I think I'll do it from that side down. And this is 1.39, so that's 390 thousandths I need to take off for an inch. But wait a minute, hold on, what's this? All right, this height is 1.07, so let's pull up my calculator real quick. All right, so wait a minute, let me just re-zero this. It's just off by half an inch. No, I'm sorry, 0.5 of an inch. 1.0725. So we'll say 1.07, and the height of this right now is 141. 141 minus 1.07 is going to be 393 thousandths and change. 393 thousandths. Alright, so I'm not going to be able to level it because I haven't machined this side smooth yet, which is a pain in the neck, but let's see, I think I'm just going to put this all the way down. I'm just going to take a little bit off just to flatten this side so then I can put it in the vise higher up and level it, because otherwise it's not going to come out right. So this is obviously not a quick, easy procedure. It's somewhat time consuming. So I know everybody thinks a CNC machine, once you have a CNC machine, everything's easy. I thought it was I didn't think it was easy. I knew it was going to be difficult because I've done jobs in machine shops, and like real machine shops that made parts for NASA, and you know, on the Mars rover they made the collection tubes. I've done work there, and they have some serious equipment. Like, I'm in awe every time I go there. Why isn't it moving? Why isn't this thing connected? Oh, there we go. All right. So those machines are even harder to program, but I knew that it was going to be difficult. You know, it was going to be time consuming, not necessarily difficult, but it was going to be time consuming, and it was when I got it. But it's even a little more than I thought, is my point. So if you guys are interested in doing this kind of stuff and you don't know about it, it's good for you to find that out beforehand, because I didn't know exactly how time consuming it was to do the things I wanted to do, even with the right equipment. It's still very time consuming. It gives me a different level of appreciation for other people's work. You know, like things that you buy, you realize what went into it when you buy it compared to not having done it yourself. So even though I appreciated what went into it before, because I do this type of stuff as a hobby, but I didn't do it to that extent. So the more I learn myself, the more I appreciate like other people's work, because the more I understand it. What is up with this button? You son of a bitch. Is that not the button that doesn't want to go down? What the fuck? See, and then you have stuff like this where I gotta reset this thing. I don't know why it's not moving. Proceed without homing. I don't want to have to home it because I don't want to reset everything. Now this side will be perfectly smooth, and I'm gonna remeasure it and redo the calculation, because then I'll know exactly how much to take off. Because before it was just uneven, so the measurements I was taking, they just couldn't be relied on. Alright. Okay. Turn the speed back up so I can move this thing out of here. What are you doing, buddy? All right, you want to go home. All right, let's home you. Home machine. Go ahead, get out of here. Go home. MR1, go home. phone home, go home, whatever. All right. Now we got 2 flat sides. So you see how nice and smooth that comes? It really machines this stuff like perfectly smooth. It's just, I can't even though you can see the lines from the different paths, you can't feel it. It's completely smooth. It's impressive, frankly, for the money that I paid for it. I mean, $8 grand, really, my lathe was like 5. So when you look at it in perspective, the lathe is an amazing machine, and you can do things on it you can't do on this. So that's why you need both. But there's so many more things that you can do on this than you can do on any manual machine. That's a manual lathe. It's not a CNC lathe, which I considered making it one, but I haven't actually obviously pulled the trigger on that. All right, so now we're at 136. Let's actually re-zero this thing, start over, 0, 136, and I need it to be 1.07, what, 1.07, oh no, I didn't have it on there. 1.37, 1.36 and a half, 1.36 and a half. The magazine, where did I put that? Okay, now this is 1.0, well, now it's 1.08. Let's re-zero it. This is why you use a micrometer. All right, 1.068, 1.068 compared to, or we're going to do 1.07 to 1.36. So I need basically 300 thousandths off. So now I can actually level this in the vise, which is why I had to take it down again. So in a couple minutes, this thing is going to stop at the 30-minute point, and it's supposed to restart itself. I don't know if it's actually going to, but I'll double check on it. That's why I've been keeping an eye on the time, because I figured that this procedure would take longer than 30 minutes, unfortunately, for all of us. I would like it to go a little quicker, but you have to make it right, or it's just not even worth doing. Alright. Almost had it completely at 0, but that's 1/10 of a degree. Alright, adding 300 thousandths off of that. The only good thing about making a design for this is if I had done a design on Fusion, I could have it make a bunch of them automatically starting from the same stock and just cut a bunch of pieces of stock and then let it keep making them. And you know, that's how people manufacture things. So you design it once and it does it on its own. Oh, let me just find out where I am exactly at the top of this, and I can take it down the exact amount. All right, let's go in small steps. I'm gonna go up to 1/1000th. All right, hold on, let's see when I get really close. Okay, I'm pretty damn close. Let's move it a little more over it, because I want it to be touching the top when I measure it. Okay. I think that's gonna be it. All right, let me just open this door. And a little bit more. 4 more thousandth of an inch. So where am I now? My z-axis, I'm at -1.1. So there we go. It did it again, and for some reason this thing is not overriding it. It's not making it start recording again. That's why I ordered a GoPro. It's supposed to be here today, so hopefully that is here today, and I can start making videos that are not interrupted. So now that I know how far I'm going, I can go a little bit faster, because I can just get that number on that axis. And sorry about that, hold on 1 second. Once I get the Z-axis to where I need it, I know where I am, so I don't have to worry about going such small increments anymore. We'll speed this up a little bit. Let's speed up the spindle a little bit. Let's go to 6,500. All right, and move this a little faster. All right, we'll speed this up a little bit. This machine's just capable of so much more. So instead of doing a plunge cut, I'm going to bring it down and then bring it in. That's right about where I need it to be. Just plows right through. Not even slowing down with that big chunk. Money's so well spent on this machine. All right, let's see. I want to go down a little bit more, but I'm going to do it in very small increments. That's going forward. All right, I'm going to go down. That's right where I want to be, right there. And I can speed back up now. Okay, let's just clean it up. You always want to just do a cleaning pass in case you know, the blade didn't hit exactly the same spot everywhere, or there's some, you know, shards left. I mean, you could always, you know, clean it up with a wire wheel or something, but why when you can make it perfect? All right, so that should be the exact right size. I should be able to slip that right in the gun right now, which I'm actually going to do another video on the adjusting the regulator on that Rapid Airworks, because it's actually kind of complicated, believe it or not. It's not like an FX where you just turn a screw. You have to actually take the bottle off to do it. So now I don't need it to be this big, but this is the right height and diameter that this should slide right in the gun. So maybe should I bring you guys, or should I bring the gun in here? Maybe I'll just grab the gun. So I'm gonna leave the air compressor. I'm gonna leave the camera, but you guys are coming with me with my voice. All right. Okay, let's see. Let's take this magazine. Oh yeah. Perfect. All right, you guys will see this in a second. That is absolutely perfect. And then if I could even go further and make the channel in it for the end of the barrel, which is what the magazine has in it. So I could actually do it off of the magazine, but I don't even have to do that with this. I probably should actually do it though. but then I will have machined this down a little too far. Because I'm going, the size of the magazine is the size of the inner part at that spot. So anyways, this is what I'm talking about. So here it is. You can see this is where the magazine goes in, and this is going to fit right in there, and it's the same height and it's the same width, and it slides right in. So that'll have a channel in it. See, and it'll stop right there. When it's all the way down, it'll stop right there. Okay. And I could make a small channel to go around the barrel tip, this little bit here where the barrel sticks out. I think I may actually do that. Let me see what the diameter of that is. Maybe I'll just take a smaller end mill, square end mill, and make it cut that. Okay, razor this. That's 39 thousandths. Okay, 39, or it's 0.39, it's 390 thousandths. So let me see what size bits I've got. I have all the metric and standard sizes pretty much. It's gonna be too small, maybe this one, maybe a 3/8. Yeah, well, 3/8 would be right about there. That's 0.29 actually. So just a little bigger than a 3/8, which may be a metric size. Let's see what that is. No, that's a little bit bigger, but not much. Not enough. Those are definitely too big. No, that's a ½ inch. That's way too. That's actually 5/8. That one might be it. Let's see what this one is. Oh, there we go. That's 3/4, 3/5. That 35 is actually going to come out pretty close when you with the barrier that it's going to have in the middle. Yeah. All right. This one's not any closer. That's going to be the closest one. All right. So I got to change my what the hell are those things called? Oh, the damn sleeve that goes in there. I forget the name of it. Okay. This is my collet. The collet size I have to change. All right. I'm going to use this. So which collet do I need for this? That's too small, that's too small, that's too small also. There, it's not much smaller than this one. Some of these are actually brand new because I've been using a chuck on the drill for the milling. So I had to buy this whole collet set for this, which actually that was part of that price too. All this stuff, actually one set of bits, one set of the bits, one set of threading bits. So a set of square end mills, a set of thread bits, a set of collets, both of the two big vices. That's all included in that price. And the enclosure, you know, I did some additional stuff to it, which I made a short video about previously. All the stepper motors, everything except the cement, even the epoxy I bought from them, because they do actually sell marine grade epoxy with it. This is some serious shit. And I actually only needed half of it because it's so damn thick. And it's self-leveling, it's really good stuff. That one's in there pretty good. Let me try to get it out of that rubber mallet. Where's my flooring hammer? I don't want to use a regular hammer. Where's my flooring hammer? Excuse me, guys. Always something, right? Where's my... Maybe I could just use a vice grip or something. Let me just grab a pair of pliers over here. Oh, there we go. That's in there pretty good. I'll have to tap that out. Yeah, this is why you have to use these, because they work. They really tighten this bit in here like no chuck is going to. Even the lathe chuck doesn't cramp down on stuff this hard. So this should be just one pass, or not even a pass. One time going into it should make the diameter of the channel for the barrel, and then it should stop where this channel stops. So I have to do it on a different face of the part. I have to do it on this face, and then I have to see exactly how high up I need to start it. That's the diameter. The height is going to be very hard to measure. Hold on one second. All right. That's an inconvenient spot, to say the least, to measure. All right, it's going to be right at like 330 thousandths. So it's going to start right there. I need to mark that some. I need to get some kind of a fine point way to mark. I mean, I have a fine point marker, but that's not what I need. Actually, you know what? I'll mark it with a knife or something. That'll be way more accurate. Let me put a fresh blade in my utility knife, because I was cutting roofing material yesterday. All right. So this is going to go in this way. This needs to be the height off the bottom. Okay. So from right there, that's the bit is the diameter, and then how far in do I want to go? I mean, I could just go halfway and cut the excess. Let's see. It's going to be on that side. So it's going to go like this. Alright, so this should actually be a little fatter. I cut it down a little too far to do this, but I'm doing it anyway. Alright, let's get this level. And these are actually really good vices. These were, of that $8 grand, these were $400 a piece, and worth every penny, because if you have a big piece of material, like for example the Pantera rail that I've been designing, I haven't cut it yet. How am I gonna hold this down without having two vices like that? You need the length. You need both of them, because you can't hold it with one. If you put one in the center, it's not enough for this. You know, when you're at the left and right side, it needs to have stability. So when you're cutting it with a tool like this, it just has to be, you just need the vices. It's just the way it is. But they're worth it. They're totally worth it, because they make you capable of doing stuff like this. All right, let's see where we're at there. Let me put this crap down. And then I have to make sure my mark is in the right spot. There it is, okay. Let's level this. So I probably will make this video a little shorter. I'll just put the highlights, I think, because I'm sure it's probably boring. And then I'm just talking because I'm bored as you guys. That's gonna go back up. Too far down, too far up, too far down, too far up. Alright, come on. You have to make such small movements while it's in a vise. It's a pain in the ass. It's almost there. Alright, 1/10 of a degree. It's almost impossible to get it any closer than that. All right. So as long as let me just line the tool up with this line first. Now I need to start getting some small movements. All right, let's turn this all the way down. You know, I'm gonna take my small little ruler in here. Oh, and this dial indicator I got with it too. The small one on the side right there. Let's see. It's gonna go a little over. Sometimes it gets so close you can't really see it with your eye. That's why the computers are necessary, but there's ways to tell with these precise measurement tools. That should be it right there. All right, I'm gonna start it from right about here, and then I'm just gonna go down until I just barely touch, and I'm just gonna make a small groove because it's so close already. I may make it another one and make it exactly right, and you know, a little bit wider, but to make it perfect if it bothers me that much. But all right, I'm going to keep this increment small while I go down because I just want to barely be in the material a little bit. So maybe a few thousandths after I hit, which is right now just hit. We'll do 2 more thousandths and that's it, and then bring it out. All right, that looks like it's it. Now I should do a top pass, but I just don't want to. I don't want to mess anything else up. I could just shave that off with a file or something, or my belt sander. A benchtop belt sander, obviously you want to use. All right, now I have to just make the channel for the pellet, and we're done. So it's not too far off right now. Okay. So you see what I just did is make this little groove in it that you can probably see, just to go that far. I didn't make it very deep at all because it's already kind of shallow. I did it right to the barrel end, which I probably should have made it a little bit wider, but this actually will be enough to stop it, I believe. I'm just gonna run this over the sander real quick, just to take that scuff off. You don't want to take any material, you just want to take the loose aluminum pieces, which normally I would just machine back over the top, but I don't have everything measured and in the oh, that's nice, it does stop it. It slides right in right there. I could have went a little tiny bit deeper, but yeah, I should probably go a hair deeper. But really the whole thing needs to be a little bit deeper if I was going to do that. I should have done that, but it is what it is. So I'm going to put it back in, and I'm going to do one more pass through that to make it just a little bit deeper. Just a tiny little bit. Alright, let me level it again. So I'm sorry this is taking a while. You guys obviously can fast forward. I do a lot of times on other people's videos. But generally, this type of thing I don't, because I want to learn all of it. But like when people are hand turning screws and stuff like that, I'll fast forward through that. Which, no offense to anybody, I mean, I hand turn them sometimes too, but when I'm doing a video, I try to be a little considerate as much as I can, but certain things you have to do by hand, unfortunately. So that was actually 0.0 level completely. All right, let's start it off at 25, get it over here. Bring this down. Alright, I need the smallest movements now so I can line that up exactly. So this is one of those situations where I'm going to say do as I say, not as I do, because I probably shouldn't be sticking my head in here with it running, but that factor of fear escapes me, which is why I'm often injured, which is not a path I want anybody to follow. Alright, perfect. Nice, right there. Alright, let me just speed it up a little bit. Nice, okay. Alright, shut that off. Okay, actually let me get it up and out of the way. And by the way, it's not something I'm proud of, I mean, that's how I learned how to do a lot of the things I know how to do, because I'm not afraid to try it. I'm not afraid of a whole lot of things. I mean, that doesn't mean I'm a badass or something. It just is what it is. Because in a lot of ways, I'm not a badass at all compared to some other people, but in a lot of ways, I do things that most other people wouldn't. I really should have took even more. Son of a bitch. I'm literally going like 1/1000th of an inch at a time. Alright, so I'm probably going to do one more and just do it as quick as I can, because I think it's going to fit right in there, even though it's not perfect, because it should have been a little thicker if I was going to do this, which I obviously just decided to with you guys on this video, but now that I'm trying to do it, if I make the groove a little bit bigger, it should sit in it pretty well. All right, it was at 0.0, now it's 0.1. All right, that's pretty fucking close. All right, let me get this right in the right spot. See, the designing, once you do the design on the computer, you don't have to do any of this. You don't have to measure anything. I mean, you have to measure it while you do the design, because it's going to ask you all this stuff. It's going to ask you every single measurement. So you're gonna end up measuring all these things one way or another. But I guess, honestly, it doesn't really make a difference. I probably should have done it on the software, because now doing it, it seemed like something that would be really quick, but it hasn't been all that fast. I mean, it's still less than an hour, but that's not the fastest thing in the world. So what I'm going to do is, I'm going to finish this up. I think the most important stuff I wanted to cover with you guys is pretty much covered. I wanted you to see how the machine works, how the software works, and how I was going to make this, and why I was making the cuts I was making, and where they were going to fit, and all that. And that's pretty much it. So I wanted to show you guys all that stuff, which I have. And I will definitely include another clip with a finished product and what else I did to get there. But I don't want to make a 3-hour video. So I don't think it's going to take 3 hours, but I think it's going to take more than another 5 or 10 minutes. So the only cut I have left is for the actual pellet and the size of the block that I actually want it to be, which, oh nice, now that sits in there good. See, now if the whole thing was fatter, it would be perfect right now. It would be totally perfect. Yeah, I should have made this fatter because that would have sat. It would have stopped right there. Wow, dude, that, just a little bit fatter and exactly like that. But you know what? That once it's in there, it'll sit. Like it just was stuck on there for a minute. But yeah, right there. All right, so let me mark both sides of that from where the center is, and then I'm gonna start making the channel. All right, that's one side. This is the other side. All right, so it's right in between those two. And then I think I'm going to cut this down. So this is the width of the gun. I'm going to take this side. I'm going to leave that channel. I'm going to take this side down a little bit, like very close to probably right at that opening, and the other side's going to stay up a little bit. And then I'm gonna leave it. I'm going to cut it right about here, and then maybe I'll let it stick out a little bit on one side, on the shorter side, because that's where you're going to put the pellet in, so it'll have room to roll in. So what I'll do is I'll probably cut this with the bandsaw, clean it up on the machine, and then I'll make that straight cut, clean that side up with the machine, and then I'll cut this side all with the machine. I'll lower that. I mean, I could do it all in there, but it's gonna be faster just to make a bandsaw cut in one pass, and then this side I'm gonna have to all do with the machine. So that's what I'm gonna do. I'll make another clip to add to this for a finished product, so you guys can see how it came out, and look forward to seeing everybody after the competition other than this, and possibly I'll make another accuracy video. Oh, and then the regulator for this. So I'll probably do the regulator and the shooting video with the 3 guns that I'm going to be primarily using, with a backup for each, obviously, or at least one backup for the 2 20 foot-pound of energy guns and another for the bench rest gun. Okay, all right guys, so I will see you soon. Bye.